Okay, so now let's do some, let's practice now finding the LCD. Okay, it's not terrible, you know, but let's do it. So here's our first example. So we have these two rational expressions, okay? And the denominators here, they're already factored. Normally, you have to factor them first, completely. Okay, now what are the irreducible factors? Well, we can see that we have x minus 1, right? That's 1. We have x plus 2, that's another factor, and we have x. It doesn't really matter what order you list them in. So we have x minus 1. X minus 1's listed already. Don't list it more than once. We have x plus 2. Now, for each one, you list the biggest exponent. Sometimes, like here, you'll only have a factor in one denominator. Okay, you may have that. Then you just list its only exponent. So for instance, x is here, but not in this denominator. Its only exponent is 1. So the 1 goes here. X minus 1, we have 1. We have 2. So 2 is the biggest exponent. X plus 2, right? We have a 1. That's the only exponent, so that goes here, as you can see. Okay? Beautiful. So now what is the LCD? Well, we do x to the first times x minus 1 squared times x plus 2 to the first. That's what we have here. And from here, okay, we get x times x minus 1 squared times x plus 2. That big product here is our LCD. Now we're not going to do the rest. Well, normally what you would do if you wanted to add or subtract those rational expressions, this LCD would be your denominator, and you would have to manipulate each rational expression here in order to get a common denominator. Let's move on and practice finding the LCD for others as well. I mean, the idea you can see is not that terrible. It's very similar to for when you're working with rational numbers. So for this one, we have these two. Again, we're looking for the LCD. So for this first one, as you can see, okay, we have this denominator. It's not factored. We can factor it. The second one is already factored. Let's just factor the first one. So we get then x to the fourth plus 3x cubed minus 4x squared. Right away, we can take out x squared, right? That's the smallest power of x that occurs among every term. So that comes out. Get this. We have x squared in front. Now we're dividing like so, as you can see. We're dividing, right? We divide to see what's left over. So we get x squared times x squared plus 3x minus 4, as you can see. Good. From here, we get x squared plus 3x minus 4. That's going to, okay, now we want to factor this. Well, again, it's just like the other ones. We need two numbers whose product is minus 4, but the sum is 3. Well, as I have here, let's use 4 and negative. So from here, okay, we're going to have x plus 4 times x minus 1. So putting it all together, this denominator becomes this thing. And that's what we get there. Okay, so now when the denominator, with the denominators factored completely, We have these two to deal with, as you can see. Good. All right, so from here, right, we want to get the LCD, so they're factored. Let's list the irreducible factors. We have x, right? We have x minus 1, x plus 4. Now if we're in this one, x and x minus 1 are listed. X plus 6 we list. X plus 4 is already listed. Now we list their largest exponents among the denominators. So for x, we have 2 and 1. We take 2. This one, x minus 1, we have just 1 and 3. So 3 we take. X plus 4, we have 1 and 5. So we use 5. X plus 6, we use, there's only one exponent, 1. X plus 6 is not here, so we just use 1. So our LCD is this. X squared times x minus 1 cubed, x plus 4 to the 5th, times x plus 6. That's what we get. Good. All right. Are there any questions about that? Oh, well, I guess, that's why I got up to other class. I really don't want to end here, so let me get to my other notes. 11 day, I just had it open. Well, let me just open it. I have it. 1 second. But I will get to this a little bit more. 2. Here it comes. I don't want it. Chapter 11. P5. There it is. And let me just share it. Okay, although here I guess, well, I don't really have much time to do these, so we'll probably do them next time. Let me start with the next material. I will cover this as well next time, but let me at least start going through it. Let's see if I can find it. Here we go. Basically, what we're going to see next time is how we can use the LCD to actually add and subtract these rational expressions. It's just like, again, with rational numbers, what we're going to do is we want to manipulate so they have the same denominator. And for us, okay, what we're going to have to do is something like this. If you remember with rational numbers, I mean, I know we didn't go through it that much in this class, but in previous math classes, maybe even in high school, you would multiply the bottom by a certain number, right? But you have to do the same thing to the top. And that's basically what we're going to do here. Okay, so for instance, it turns out for this one, we'll see this example next time as well. Let me just quickly go through it. So you get the LCD once we have that here, right? To actually add these two, we're going to have x minus 2 times x plus 1, right? Because we want the LCD. The only thing missing is x plus 1, as you can visually see it. But you have to do the same thing to the top. What you do to the bottom, you also have to do to the top, remember. Okay, so I do that. I multiply the bottom by x plus 1, the top as well. Same thing over here. The LCD is missing, the denominator is missing x minus 2. So we're going to multiply the bottom by that, the top as well. See? And now we have two common denominators. We have the same denominator. And then it's just like adding, just like before. I mean, I don't want to go too far ahead of the other class, so let's see. I think we're going to end a minute early, but that's okay. I don't think hopefully no one has a problem with that. All right, no one here.